Alright, so this video will be talking about the Snell's window. So what is a Snell's window? So imagine that we have a lamp underneath a swimming pool and you put your eyes above the swimming pool right here. So what you will see is actually a circular light with dark edges or dark thingy at this part. So what is happening? So of course, if you look at this left hand side picture, right, you'll see that the light ray the first light ray is going to exit the water perpendicularly to the surface of the swimming pool. So it's not going to refract and go into the air and of course into the eye. So that is the very first light ray. The second light ray is going to reflect because the second light ray is at some angle. So you're going to, when you exit the air, right, it's going to reflect away from the normal. Okay, the third light ray is the one that is the interesting one. So the third light ray here, because the third light ray makes an angle of incidence equal to the critical angle. So the light ray is just going to travel on the boundary of the water. So this part, right, from this part onwards is the dark part that you see if you put your eyes on top of the swimming pool. Alright, so whatever that you can see, right, so for example, if you are looking at this part, so this portion right here, so this portion right here is actually corresponding to all these light rays here, because the light ray is exiting the water into the air. So anything that exits the water into the air is something that you can see. So that's why this part is the thing that you can see. Of course, on the right hand side, on the left hand side, same idea. The second light ray is going to bend away from normal. So from this part onwards is the thing that you can see. So this part, right, is actually this particular part. So that is the meaning of Snell's window. So beyond the pink color part, right, is actually this part. So this part is this part. Alright, so that is the idea of Snell's window. So just take note of how the light ray will cause a cone of light forming out of the water. Okay, so let's take a look at this trial itself for. So of course, you can try this question first before you look at the answer. So okay, imagine that we have a small lamp which is 2 meters below the surface of the water in the middle of a large swimming pool. So two rays from the lamp strike the surface at X and Y. So the critical angle for the light passing from water to air is 49. Okay, so let's take a look at the question A. So explain in words, right, what is meant by critical angle? So 1 mark. So critical angle is the angle of incidence in the optically more dense medium in which the angle of refraction in the optically less dense medium, right, is equal to 90 degrees. Okay, so for part B, on figure 6.1, complete the path of the two rays, right, after they strike the surface at X and Y. So 2 marks. So first mark is the X, second mark is the Y. Okay, so if you look at X, okay, the light ray is going to form, is just going to exit the water. Why? How do I know that? Because if you draw the normal, the angle here is definitely less than 49 degrees, which is the critical angle. So if you are less than critical angle, you are going to exit the water. So you need to bend away from the normal. So the second is the part Y. Okay, point Y, right, you are exactly at the 49 degree, which is the critical angle. So you have to travel on the boundary of the water air surface. So okay, so imagine that I draw one more light ray. So if I draw one more light ray, so the lamp is right here. So I draw a light. So this light will form an angle here. So this angle is still less than 49, but it's going to bend away from the normal. So let me just draw here. So I bend away from normal. So this is how I draw the different light rays corresponding to the different parts of the lamp. Alright, okay, so Okay, so part C, when viewed from above the swimming pool, right, light from the lamp emerges only from a circular area of the water. So this is known as the Snell's window. So you can see that the light is going to form a circular area of the water. So explain why this happened. 2 mark. So the first mark you talk about the so-called the circular area, the thing that you can see. Then the second mark you talk about the dark areas in which the light doesn't exit the water. Okay, so the first credit you just have to say that okay, the light. Okay, so in this context, the light that is exactly above your lamp. So let's talk about exactly above the lamp, all the way to point Y is going to exit the water. So okay, so the light from above lamp to point Y will exit the water as the angle of incidence in water is less than the critical angle. So that is the first part. So second point, you talk about something, the light that is beyond point Y. So you can talk about point Y and beyond point Y. So at point Y, the light angle of incidence is equal to the critical angle. So after that, you can also talk about beyond Y, the angle of incidence is above your critical angle. So it will undergo total internal reflection. So when it undergoes total internal reflection, right, so the light will not exit the water. So this actually form a circular area of the water. So for point number two is the dark areas that you see lah. Then for point number 1 is the circular area of the water. Okay, for part 2, calculate the radius of the circular area of the surface of the water. So let me just copy this. Okay, so if you look at this, right, they want the circular radius. So this green color shaded region is actually the circular radius. So how do I do this? So first thing, you must use a bit of tuakaso lah, the simple tuakaso. So let's draw this pool of water. So of course the lamp is 2 meters beneath the water. So this is the lamp. Okay, so next thing is I draw here. So 2 meters. So I draw 3 light rays. So first light ray, I will just have to draw in this fashion. Okay, so the second light ray, first light ray is just going to exit lah. The second light ray is going to just be here. So this is point X. And the third light ray, I will draw in this. So third light ray is here. So the circular radius is actually from this point all the way to this point. Alright, so that is for point 1. Okay, so how do I do this? So first thing first, I want to use for this. Okay, I need to use this picture. Okay, so I need to draw this. Okay, so you can see there's a right angle triangle. I erase this. Okay, so there's a right angle triangle, and we know that this is a 90 degree, right? So 2 meters is right here. So 2 meters. So I want to find what is this distance. Because as long as I find this distance, I will know the so-called radius, right? So this is the radius. So I just need to use tuakaso, and I'm given the adjacent. I just need to find the opposite. So opposite is, how do I find it? Tangent 49 degree is equal to oppo over adjacent, right? So tangent 49 to tan 49, you should get roughly opposite angle of opposite length of 2.30 meter. So the radius of the circular thingy is actually 2.30 meter. So that's how we solve this type of question. So so if I draw the full window right here, so the full window, if you look above the water, okay, so this is the window. So beyond this circular thingy, is actually there's no light emitting out. So the only light that you can see is actually within this circular area. So of course this circular area, so this will be the radius. So this radius will be 2.30 meter. So that's how we see how we solve this question. So yeah, all right. So this is 2.30 meter. Okay, yeah. So that's about it for this chapter.